Hello my dear wonderful genius students, I'm back again with a new video. This is lecture number 21 on complex analysis and today's topic of discussion is Taylor's theorem. First, let me write the statement of this theorem. Statement: if a function f of z is analytic, if a function f of z is analytic at all points within a circle modulus of z minus a equal to r, then for all points within this circle the function f of z can be expanded about z equal to a as follows. F of z is equal to f of a plus f prime a divided by 1 factorial into z minus a plus f double prime a divided by 2 factorial z minus a whole square plus plus f to the power n a divided by n factorial into z minus a whole to the power n plus . Now, let us understand what is the actual meaning of this statement. Students, suppose we have a circle C whose equation is given by modulus of z minus a equal to r. That means the radius of the circle is capital R and the center is located at the point z equal to a. Apart from that, we have a function f of z and this function f of z is analytic at all points within this circle. By analytic, I mean to say that this function f of z is continuous and differentiable at all points within the circle C. If this is true, then according to Taylor's theorem, we can expand this function f of z about z equal to a in this way. F of z is equal to f of a plus f prime a divided by 1 factorial into z minus a plus f double prime a divided by 2 factorial into z minus a whole square plus plus f to the power n a divided by n factorial into z minus a whole to the power n plus . Next, let us consider one special case where we are going to expand f of z about the origin, that means about z equal to 0. If we expand f of z about the origin, then the resultant series is known as the Maclaurin's series. Now, let me write these points. Note: if we expand f of z about z equal to 0, then the resultant series is called as Maclaurin's series. That is, f of z is equal to f of 0 plus f prime 0 divided by 1 factorial into z plus f double prime 0 divided by 2 factorial into z square plus plus f to the power n 0 divided by n factorial into z to the power n plus dot dot dot. So, for this case, the radius of the circle is capital R and the center is at z equal to 0. Now, let me derive the formula of Taylor's theorem. Students, suppose we have a point Z inside the circle C, whose radius is capital R and the center is at Z equal to A. First, let me write these points. Suppose Z is any point, Z is any point within the circle C having radius capital R and center at Z equal to A. Next, we draw another circle C1 within this bigger circle with A as center, such that this circle C1 encloses the point Z. Now, let me write these points. Next, we draw another circle C1 with A as center, such that this circle C1 encloses the point Z. Next, I am considering a point W on the circle C1. Now, let me write these points. If W is any point on the circle C1, then we have 1 by W minus Z is equal to 1 by, this denominator can be written as W minus A plus A minus Z. Now, let us rearrange the terms of the denominator. 1 by W minus A minus Z minus A. Now, let us take common W minus A from the denominator. So, finally, we will get 1 by W minus A into 1 by 1 minus Z minus A divided by W minus A. So, this part can be written as 1 by W minus A into 1 minus Z minus A divided by W minus A whole to the power minus 1. So, finally, we get 1 by W minus Z is equal to 1 by W minus A into 1 minus Z minus A divided by W minus A whole to the power minus 1. Now, let us expand this term with the help of binomial theorem, and according to binomial theorem, 1 minus x whole to the power minus 1 is equal to 1 plus x square plus x cube plus dot 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 x to the power n plus dot dot dot. So, let us expand this term. So, we will get 1 by W minus A into 1 plus Z minus A divided by W minus A plus Z minus A divided by W minus A whole square plus dot 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 plus z minus a divided by w minus a whole to the power n plus dot dot dot. Now let us multiply this term with this term. So finally we will get 1 by w minus a plus z minus a divided by w minus a whole square plus z minus a whole square divided by w minus a whole cube plus dot 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 plus z minus a whole to the power n divided by w minus a whole to the power n plus 1 plus dot dot dot. Suppose this is equation number 1. Again we have seen that this numerator is less than this denominator because z minus a is less than w minus a. So from this we can say that this series converges uniformly. Since this series converges uniformly, we can conclude that this series is integrable. Now let me write these points. The series is integrable. The series is integrable because it converges uniformly. Since modulus of z minus a divided by w minus a is less than 1. Now multiplying both sides of equation 1 by f of w we get. So multiplying both sides of equation 1 by f of w we get f of w divided by w minus z is equal to f of w divided by w minus a plus z minus a into f of w divided by w minus a whole square plus z minus a whole square into f of w divided by w minus a whole cube plus dot 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 plus z minus a whole to the power n into f of w divided by w minus a whole to the power n plus 1 plus dot 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 equation number 2. Now integrating equation 2 with respect to w we get integrating equation 2 with respect to w we get integration along curve C1 f of w divided by w minus z dw is equal to integration along curve C1 f of w divided by w minus a dw plus z minus a integration along curve C1 f of w divided by w minus a whole square dw plus z minus a whole square into integration along curve C1 f of w divided by w minus a whole cube plus dot 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 plus z minus a whole to the power n into integration along curve C1 f of w divided by w minus a whole to the power n plus 1 dw plus dot dot dot. Next, let us apply Cauchy's integral formula. So, according to Cauchy's integral formula, integration along curve C1 f of w divided by w minus z dw is equal to twice pi I into f of z. So, twice pi I f of z. Again, the value of this integral is twice pi I f of a. So, integration along curve C1 f of w divided by w minus a into dw is twice pi I into f of a plus z minus a into the value of this integral. We know integration along curve C1 f of w divided by w minus a whole square dw is twice pi I into f prime a, twice pi I into f prime a plus z minus a whole square. Again, integration along curve C1 f of w divided by w minus a whole cube dw is twice pi I divided by 2 factorial f double prime a plus dot 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 plus z minus a whole to the power n into the value of this integral is twice pi I divided by n factorial into f to the power n a plus dot dot dot. Now, let us cancel out twice pi I from both the sides. So, finally, we will get f of z is equal to f of a plus f prime a divided by 1 factorial into z minus a plus f double prime a divided by 2 factorial into z minus a whole square plus dot 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 plus f to the power n a divided by n factorial into z minus a whole to the power n plus dot dot. Suppose this is equation number 4, which is the Taylor series expansion. Which is Taylor series expansion. This is all about today's video, and in my next video I will solve some numerical problems by using Taylor's theorem.